All right, so the more difficult problems, I really do like to make it more visual, something that I can see what is going on better than reading through this complicated or very long paragraph. So, starting off, Miss Davis wondered if the height of a hole punched in the side of a 2-liter bottle would affect how far the container of liquid would spurt when the carton was full of liquids. So she used 2-liter bottles, punched the same size. Okay, that's right there. We're seeing two words, identical and same. That means they are going to be the control variable. Anything that stays the same or is identical, we know that it is the control variable, the thing that stayed exactly the same through the experiment. So keep on reading real quick. The hole was placed at different heights on each side of the containers. The heights of the holes varied in increments of 10, ranging from 10 to 40. Okay, right there I see automatically that I'm changing something. So I have the height of the hole, okay, and I'm going from 10 to 40. So I have 10, 20, 30, and then 40. So that's the different heights. And what did we say stayed the same? Well, the 2-liter bottles stayed the same throughout the experiment, and also the size of the hole. So that'd be hole size also stayed the same. So this is kind of setting up my idea of how to draw them out because we see, well, we've got one experiment at 10, one experiment at 20 and 30 and 40. These are staying the same. Okay, that's giving me information already. So control variable is the 2-liter bottle and the hole size. I am changing something here. I've got 10, 20, 30, 40 being changed. So that's the independent variable. So that is the height of the hole is being changed. And so it goes on to say she puts her finger over the holes, fills the bottles with liquid, then she placed the bottle in the sink and removed her finger. She measured how far away from the bottle the liquid squirted. So here's our word, counted, measured, recorded, or observed. She measured how far. Well, how far is a distance. So dependent variable is the distance liquid squirted. Okay, but now we still have something else to figure out, the control group and the experimental group. Well, experimental group means that we are messing with it. So we messed with a 10 centimeter hole and 20 and 30 and 40. So we messed with all of these. So these are the experimental groups. But where's our control group? Well, remember the control group means that it was nothing done to it. It just stayed normal. So is it normal for a 2-liter bottle to have a hole in it? Well, no. So our control group would have to be 0 height. There's no hole in it. So that right there is going to be the control group. It still has the, well, 2-liter bottle, no hole, no centimeter. So, you know. So our control group is the bottle without a hole, the normal bottle. And then the experimental group would be the bottle with the 10, 20, 30, and 40 centimeters. 10 through 40 centimeter holes. All right, so we kind of were able to draw this out. I would suggest you do it to every one that you come across. So I'm going to do it to one more to see if we can kind of keep it rolling for you, keep you kind of thinking it out. So let's talk about number 6. And it says, while a construction crew was digging a pool in her backyard, Ashley observed that different kinds and amounts of fossils were present in the area behind her house. She wondered if changes in fossils fossil content occurred in the same pattern as one dug from the surface to deeper areas. So Ashley marked the bank of the cliff at the end of their property at 5 positions. Starting at the surface, she marked every 5 meters. Okay, so I see something changing here. She started at 0, which is the surface, and then she went to 5, 10, 15, 20, and 25 meters. So she's saying she's digging down surface level 0, then she's going to dig down 5 meters, 10 meters, 15, and so on, and she's going to remove 5 buckets of soil from each of the positions and determine what kind and number of fossils are in each sample. So here she is. These are the depths that she's digging. Okay, what is she going to pull? Well, 5 buckets. So those are going to be exactly the same through there. And let's see, what else? She removed 5 buckets of soil from each of the positions to determine the kind of fossils in each sample. So as the independent variable, what am I changing? Well, what Ashley is changing? Well, she's changing the depths at which she digs. So depth buckets pulled from. Okay, what is the dependent variable? What is she measuring, recording, observing, or counting? Well, she wants to observe the kind and number of fossils. So it is the kind and number of fossils. So the control variable, what's going to stay exactly the same throughout the entire thing? Well, 5 buckets. Now, it doesn't exactly say it, but is she going to take like a 5-gallon bucket from one place and only a little 1 gallon or a little pail, sand pail from another? Well, no, the bucket would have to be the same for all of it. So it is the same 5 buckets. So what is the control group? What is the thing that is going to be normal? Well, it's not normal for something to be, the ground to be dug through, but what's normal is our surface level, just walking on smooth land, the ground. That's our normal, so that has to be our control group. So our normal is our control group, which would be surface level. And the experimental group, well, what is she changing? What is she messing with? She's messing with the buckets that she pulls from the 5, 10, 15, 20, and 25 meter depths. So groups 5 through 25 meters. That's your experimental group. So it's just kind of pulling out what I do know, what I am seeing, and putting it into a visual thing that I can easily pull out the information. A lot of times you'll also be faced with a problem that says, you see this graph. What is the independent variable? Which one is the dependent variable? Well, here's my trick for that. And I thought I would just add it on here. Here's our graph. And if it does like this, and we got a line graph, okay. The independent variable is going to make an I at the bottom on the x-axis, and the dependent, the thing that is changing, is making a D on the y-axis. So for this example, we would be 0, and then we would have 5, 10, 15, 20, 25 meters. That is meters that she pulls. And then what is our dependent variable? The one here would be the number of fossils. All right. So just kind of a quick thing. If you ever get a worksheet that has graphs and you have to pull information from it, just go ahead and do this on it. That way you can tell that the independent is on the x-axis while the dependent is on the y. And it's just kind of an easy way to identify it too. So hope this helps. I will see you all on Friday. Thank you.